All right, let's talk about error boundaries. So like I said, this is going to be the only class component you ever have to write because currently error boundaries are required to be class components. But don't worry, I'm going to help you with this. And hopefully those docs also helped you get kind of a feel of how you could write one of these yourself. So remember how earlier we had a problem because we were accidentally sending null to Pokemon here. And so when we clicked on one of these, we had a giant white screen of death and it was just super sad because we're trying to read image of null. Yeah, not cool. So while runtime errors like this are problematic and you should probably just fix them, they do happen sometimes. Even if you're using TypeScript or some typed version of JavaScript, you can run into these on occasion. And it would be better to show a useful error than a white screen of death where somebody has to pull up the developer tools to figure out what's going on. So what we're going to do is create an error boundary that will catch this kind of error. And I'm going to just leave that like it is as it is right now. And we're going to make our own error boundary component. To do this, we need to make a class called error boundary. And that's going to extend React component. And every component that is a class component needs to have a render function. And that's basically the body of a function component. So then we're going to return this .props.children. So this is just going to be a wrapper around wherever we put it. So I'm going to take this error boundary component as it is right now, and I'm going to wrap the Pokemon info component. Okay, cool. So now we're seeing everything being rendered fine. The only difference here now is we have a wrapper component. So we can see our Pokemon form, and we see our error boundary, and then Pokemon info down here. So we've just got this wrapper in place. So now to turn this error boundary into a component that actually handles errors, we need to add a static property called getDerivedStateFromError. And that'll give us an error, and then we can just return an object of the state that we want this error boundary to have when there's an error in itself or any of its children. So we're going to take that error and just put it into state. So let's go ahead and initialize that state. We'll say error is null. And now I can console.log the error, and we'll give this a label, error boundary. And let's get that at a lowercase o because that looks funny. And the error is actually going to come from this .state.error. And now if we save that, I open up my console, we choose a Pokemon, we try to render it, and boom. So we start out with error boundary of null, and then we get this big error. And error boundary, now it does have an error. And so now we can render something else instead of the children. And you'll actually notice that we keep on getting the same error over and over again. And that's because we're making network requests. So this error boundary handles the error, but then it just returns this.props.children. So it continuously re-renders the Pokemon info component, which continuously makes this effect call. We don't want to do that. So I'm going to refresh here, and hopefully I didn't bring down that server. Okay, so instead of rendering the children and continuously getting us in this loop of errors, I'm going to render a fallback. So let's get that error from this.state. And if we do have an error, then I'm going to render the same stuff that we render in the event of an error within our component. So I'll just copy this. We'll return that. And so now if we do get into an error state, then we can render something that's more useful to the user instead of the children of this error boundary. So we'll save that. I choose a Pikachu here, and then, oh, we get an error, cannot read property image of null. And the cool thing is that we can actually use this error boundary to handle other kinds of errors. And so instead of rendering a copy right here, what I'm going to do is we're going to throw the error. So if we're in status of rejected, we'll throw the error, and this will be handled by our error boundary. So now I'm going to continue passing Pokemon of null, and we're going to get that error handled. But if I pass an incorrect Pokemon name and then submit that, we're also going to get that error handled by the same error boundary because we're throwing this error. And so React is like, oh no, there was an error thrown. So let me find the closest error boundary, and I'll say get derived state from error. Okay, there's the error that happened. We'll re-render this with that in its state. And because that state exists, we're going to render this instead of the children. So it's effectively doing the same thing for us, but it's not only handling the errors that we get inside of our fetch call, but it's also handling runtime errors that we get from our JavaScript. So that's a win in my book. I'm going to put Pokemon back in here. Let's just make sure we can actually get our Pokemon that we want. Ta-da! But if we type in an incorrect Pokemon, then our error boundary is going to handle that. One thing that I want to make a particular note of here is that where you place this error boundary has significance on what happens with React. So if I were to just wrap all of this, this is kind of like putting a try-catch around my entire code base. This was always a joke when I was doing Java. We'd say, oh, I need to add error handling to my Java application. So you just add a try-catch around your main method and then poof, you've added error handling. But the problem with putting error handling at that level is that you can't handle the error as well. And so let's go ahead and type in blah. We search for that and then kaboom, everything is replaced. So instead of just the Pokemon info being replaced with the error boundary fallback like this, we're replacing the entire app. So while I don't recommend putting an error boundary around every single component of your code base, it is a good idea to be more thoughtful about where you put these error boundaries. And because we're going to be making multiples of these, and the error boundary itself is pretty useful, the fallback of what we want to actually display might differ based on where we're going to put it. So I'm actually going to make a new component here called error fallback. This is going to take a prop called error, and I'm going to put all of this stuff inside of here. So we'll just return that. And then I want this error boundary to have a fallback component for that error fallback. So it's going to accept a fallback component as a prop. So this is the thing that I want it to render in the event of an error. And then I can come up here and instead of rendering all of this stuff, I'll comment that out and instead return this .props.fallback component and we'll pass it the error. All right, sweet. So with that now, I can say Pikachu, and then I have some error, and we get our fallback component. And now anybody who's using this error boundary will have the flexibility to provide whatever fallback component they want, which makes this error boundary much more generically useful for us. So in review, what we're doing here is we wanted to manage not only errors that we get from our fetch requests, but also errors that we get in runtime from our JavaScript. And so we created an error boundary, which we wrapped our Pokemon info component in. And the error boundary by default will just render all of the children. So it's just a regular wrapper. It doesn't really do anything. But if there is an error in there, then React will look for the closest error boundary or the closest component that implements this static method. And it will pass us the error, which we can use to set our state. It'll trigger a re-render of this error boundary. And because that error now exists in state, we'll render whatever fallback component the user of our error boundary provided, so we can display a nice, useful error message to our users.